Right, awesome. So here we are back. I hope. Are we back? I think we're back. Does YouTube think we're back? Stream health. Stream is healthy. Okay. Okay, Beacon Astronomy Group. Okay, Beacon Astronomy Group. Okay, Beacon Astronomy Group. Now if I can get back to the right stream, there we go, that's the one. Chat is disabled for this live stream. No, it's not! I just turned it on. What's the matter with you? Oh well. We'll just have to make do. Okay, so we saw... Now if I can get back to the right stream... There we go. That's the image of Jupiter, which is really not very good for this live stream. No, it's not. I just turned it on. What's the matter with you? So the telescope in the automatic observatory is not really rigged for planetary imaging, so it's a different skill set really. So I think what we might do is have a look for some deep space objects instead and see if we can get any images of those. So let's have a look at sky chart. Let's close that down. And Carte du Ciel, aka sky maps or sky charts. And we should be able to connect to the telescope. So I'm sitting at home, and what you're seeing on my screen, I'm at home. That's my screen at home. And in sky charts, we should be able to connect that up directly to the telescope in the observatory over the internet, and have the position displayed in sky charts. So here is sky charts, Come on. How do I make this transition to another screen? Okay, OBS Studio transition. There we go. So we have sky charts.
Connecting to drive system.
Oh, hello. That's interesting. Let's try that again. I've got a lot of transaction was never executed. Okay, that's interesting. All right. In that case, maybe we won't do that. Maybe we'll just use sky charts to see what's up. Northeast, northeast. So we want to be around to the south, really. Why can I not drag this screen all of a sudden? I hate it when stuff doesn't work for no apparent reason. That's just crazy. All right. That's never happened before. Okay. Anchor. Okay, there we go. Southeast. Let's get the south in the middle. Okay. That's looking better. And then we've got Orion rising over here. That's always a nice area to image. And we've got what's a bit higher up? Okay. So we've got Pegasus here. Which makes me think we've got the Andromeda Galaxy here, M33. Galaxy. Alexa, cancel. Apparently Galaxy sounds like Alexa now. And it has crashed. Alexa has crashed. So, all right. I think M32. Okay, so this is the Andromeda Galaxy up here. M32. Okay. We can have a go at that. M31. M31 is the galaxy, M32 is the satellite galaxy, and M110 is the other one. So M31 Andromeda Galaxy. Is it M31? M31, I'm pretty sure. So let's have a go at that. Okay. Galaxy Sun. Oh, somebody is watching. Hello, whoever you are. Alexa, are you all right?
I'm feeling super.
Okay.
To activate super Alexa mode, just say up, up, down, down, left, right, B, A, start.
Whoa, I think I found an Easter egg there. We'll try that again later when I'm offline. Oh, hi Faye. Yeah, she actually crashed, which was entertaining. Wait a minute. I didn't mean to do that.
Reconnected.
Whoa, what just happened? I've lost all my screens now. Okay, that should be over there. Let's go into here. And what were we going to do? M31, weren't we? So single image, M31. So we put in M31 in here. M31. We get the coordinates from the catalogue and they should get filled in. Oh, you've got to leave a space in ACP. It doesn't like you running them all together. Position angle 0, duration. We'll go for like a 120-second exposure and see what happens. Luminance filter, which is essentially clear. Binning, let's go with binning 2. And we will acquire. And the observatory should spring into action. Okay. Right, observing, and in the console output here we're starting to see what's happening. Okay.
Tracking on.
That's the telescope coming alive, so you can see it moving.
Start salute to Messier 3-1, Andromeda Galaxy, right ascension 0 hours 43 minutes and 58 seconds. Declination north 41 degrees 23 minutes and 51 seconds.
So it's quite high up. There we go. So in the ACP console
Slew
window
complete.
here, we can see it started running the plan. What are we doing, ACP? Okay. So it's changing the filter from O3 to luminance and starting the exposure, and it's doing a pointing update because we've moved more than 10 degrees. So this will take a short image of a star field and then try and work out the positions of all the stars and then synchronize the telescope. So here we go. This takes a little while. It's the 8-second exposure, that's done. Plate solving, so it's found 182 stars in the image. It will now look up the catalogue position it thinks it's at. Okay, it found 548 stars in
Position
the catalogue.
synchronized to right ascension 0 hours 43 minutes and 42 seconds. Declination north 41 degrees 14 minutes and 49 seconds.
Telescope is now synchronized. It now
Start slew to Messier 3-1,
position.
Andromeda Galaxy, right ascension 0 hours 43 minutes and 58 seconds. Declination north 41 degrees 23 minutes and 51 seconds. Slew complete.
Okay, now, because it's a 2-minute image, the auto guider should start. And this is a second camera which will lock onto just a single star and try to keep that in the centre of the field of view by just nudging the telescope slightly. And this is an aspect of the observatory that's really not working very well, but it does try, and sometimes it works quite well. So okay, so it's trying to find a guide star. It has found one. It's worked out, what's it doing? First exposure estimate. So it's doing about 3-second guider images. Final exposure for guiding 2.65 seconds. So it's taking 2.65 second images. Okay, there is the guide star. And we can click on that and see the star field that it came from. And this is usually quite horrible, but it's able to pick out the individual star it wants and lock onto it. And then this little area here gives you a graph of what the tracking error is. And up here we can see the exposure proceeding, so it's currently on 20 seconds of 120. And that will tick up slowly, and this bar graph will go up to the end. We can see over here that the target is M31. We're using the luminance filter, which is, it's a clear piece of glass, but it does filter out infrared for various technical reasons. It's taking one image, so we just have to wait now. So you can see the guiding status here, the error in X and Y, and we want to see this be below 1 pixel all the time if possible. So it's 0.85, it's already kind of high. And if you get perfect guiding, then this lower graph here will look like a dot. The bigger the mess that part of the image is, the worse the guiding was. And it's not going to be good because this guide star's way out of focus, and probably it wasn't near the centre of the field of view, so it's going to struggle a bit. It's not doing too bad though. Not doing too bad. Almost done. Oh, it looks like it's gone over. It's just a little bug in the web interface. Okay, downloading. Now it will download the final image, and it will try to plate solve the final image as well. Which basically means work out the positions of all the stars. Sometimes it can do that, and sometimes it can't, depending on what the image was of. There we go, look at that. In our thumbnail view, you can see Andromeda. And the plate solve worked. It solved, it matched 243 star positions, and it's turned the telescope off. Now if we click on this thumbnail, we can see a bigger view, and there we have M31, the Andromeda Galaxy. Now this is only a small part of it. It's the central core, obviously, because you can see the bright core here. This is actually, this field of view is about half a degree, which is about the size of the full moon, I think. Half a degree? I think that's right. So the Andromeda goes off the top of this picture and off the bottom, and it's actually about 2 degrees across. So you're seeing something like a quarter of the full galaxy here, and you can see dust lanes here. That's really come out quite nice, hasn't it? It's a little bit out of focus, I think. I might run a autofocus at this point to try and bring that in. That will take a few minutes, unfortunately. So down here we've got some utility tasks. We can focus the optical system. There we go.
Tracking on.
So it's just warming up at the moment. I'm just having a bit of a fidget because my chair's getting uncomfortable. Okay, observatory's moving.
Start slew to right ascension 1 hours 23 minutes and 42 seconds. Declination north 45 degrees 39 minutes and 7 seconds. Slew complete.
What's going on? All right. Exposure complete. So it's taken the pointing image. Right, the plate
Start
solve did
slew
not
to right
succeed.
ascension 1 hours 23 minutes and 42 seconds.
I have no
Declination
idea why.
north
It doesn't really
46
matter.
degrees 41 minutes and 23 seconds.
I have no idea why it does this, because it actually doesn't need to plate
Slew
solve in order
complete.
to focus. So it's just wasting time here, basically. One of the problems of running all this on a 12-year-old computer is that sometimes it just stops and does nothing for really long periods of time for no good reason at all that I can fathom. So we really need a new computer for the observatory, but who's got that kind of money hanging around? And it has not plate solved again, and it didn't need to, so we don't really care. It may try to do an all sky solution, which means sending it all off to astrometry.net and getting some third party to solve it. It can take a little time, during which the software tends to hang and not be responsive, so the web interface goes dead and won't update for a few minutes probably. Oh, I got a new subscriber. Hello Aaron, if you're watching, thanks for subscribing.
Position synchronized to right ascension 1 hours 23 minutes and 30 seconds. Declination north 46 degrees 40 minutes and 19 seconds.
Okay, all sky solutions successful, so it did go out to
Start slew to right
astrometry.net.
ascension 1 hours 23 minutes and 42 seconds. Declination north 45 degrees 39 minutes and 7 seconds. Slew complete.
So on the video, let's just swap over so you can see the I don't know if you can see the mouse over this. No, my pointer's not being captured. That's a shame. I was going to talk you through what the equipment was, but it's going to be hard to without a pointer, so maybe not. Right, so now the autofocus is run by a program called Focus Max, and this will go through a whole sequence of finding a star that's just the right brightness, not too bright, not too dim, and then zeroing in on it and running the focuser in and out and trying to predict the best focus position. And then it will take a whole series of images just out of focus and sort of use that to it averages them all out and predicts the best focus position, and then it goes to the best focus position, and then it takes another image to make sure it's done a good job. And this takes about 3 or 4 minutes to complete, and sometimes it fails. At any of these stages it can fail, but on a good day it will go all the way through and will be in better focus. While it's doing that, let's just go back to let's just go back to sky charts. Can we do that? Sky? No? Apparently that's no good anymore. Okay. Go back to sky charts and see what else there is around here to image. What's this? Oh, M45, that's the Pleiades, isn't it? NGC 1499, what's that? Bright Nebula. LBN 756. So here we can see, can we turn on a field of view indicator here? That's a TELRAD. That's not what I wanted. Let's see if I can connect to the telescope now. No, it's not having that. That's unfortunate. Oh well. What's NGC 752? Open cluster. They're boring. Open clusters are boring. Globular clusters are just marginally less boring. There's the Triangulum Galaxy up here. I think that's M33. That might be worth a look. Okay, the autofocus is progressing. Converges. Yeah, the focus has converged. It's worked out the new focus position. It's moving the focuser. And why is the CCTV gone blank? Come on. Here we go. Okay, it's doing the check exposures now, I think. So this figure on the end here is the what's called, it's basically it's a measurement of the diameter of the star that it's focusing on in pixels, in arc seconds rather. Okay, the observatory's moved a bit. The telescope's
Start
moving.
slew to Messier 3-1, Andromeda Galaxy, right ascension 0 hours 46 minutes and 33 seconds. Declination north 41 degrees 31 minutes and 28 seconds.
Okay, let's get advanced. We'll close all
Slew
windows we
complete.
don't need. We're going to do a colour series of M33. So
Tracking off.
go for the Triangulum Galaxy M33 and get coordinates. Ooh, get coordinates, thank you. And we will go with only one of each. One red, and we're going to go with a 300-second exposure. Binning 2. 1 green, 300-second exposure. Binning 2, and we're going to go with 1 blue, 300-second exposure. Binning 2. Binning means it basically on the camera it combines multiple pixels on the sensor into one pixel on the output image, so it's a way of getting pixels with a deeper well capacity, if you like. It's kind of all a bit technical, but that may be explained at one of our upcoming talks, so that'll be a good one. We just autofocused, we don't need to do that. We don't want to auto-calibrate, we don't want to do that. We don't need dithering. We need to... Okay, and I'm probably going to lose the weather before much longer, so I'm going to ask it to shut down when it's finished. So it's about 15 minutes of imaging followed by a shutdown. So acquire. Go, go, go. We are observing.
Tracking on. Start slew to NGC 604, right ascension 1 hours 35 minutes and 12 seconds. Declination north 30 degrees 46 minutes and 29 seconds. Slew complete.
So I'm just going to go over to my remote desktop into the observatory computer, and you can't see this, I don't think, but I'm going to have a look at what the weather's doing. So we've got 50% cloud cover according to the weather station, Nearest storm distance about 200 miles. No rain
Position
expected.
synchronized to right ascension 1 hours 35 minutes and 22 seconds. Declination north 30 degrees 48 minutes and 14 seconds. Start slew to NGC 604, right ascension 1 hours 35 minutes and 12 seconds. Declination north 30 degrees 46 minutes and 29 seconds. Slew complete.
Okay. Okay, the guider is starting. It initially takes a 5-second image to try and work out where the stars are and how bright they are, and then it will tone it down from there. So actually it's gone up to 6.5, so we might be looking at some dim stars here. I'm hearing some noises from the observatory that suggest it might not be going that well. Final exposure 7.5 seconds. That's quite a long exposure for guiding, but we'll see how it goes. Okay, yeah, guider unexpectedly stopped, so I thought something was going wrong there. It's trying again though. Well done. Bum 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 bum. Ay ay ay. Okay, come on. No more dings yet, so that might be... Oh no, there's one. Okay. That usually means it's not able to find the guide star. Yeah, the signal to noise ratio is 2.8, which is quite low. Okay, it looks like it's having a go. Ding. Guider unexpectedly stopped again, I think. Oh no. Oh no, what's happening? Let me zoom in a bit so this text is a bit bigger. There we go. What are we doing, ACP? Come on. Pull your finger out. You've got to talk to software, let it know who's boss. With Prince Charles, oh, King Charles, if he can talk to his flowers, I don't know why I can't talk to my software. What are we doing? What's happening? What's happening? The guider hasn't started. We're blank. Oh, it's under the... that's the trouble with zooming in. It messes the screen layout up. So there's no tracking errors yet. So the guider hasn't started, and there will be a guide star image here. So we wait. Time passes. Tempted to go and look on the remote desktop to see what's happening. Yeah, it's failing miserably. Okay, here's a thing. Let's stop that because it's not going to work. There may be a loud noise shortly. Okay. What we will do instead then is we will put position angle 90, which will rotate the rotator 90 degrees. And you might just be able to see that happen if let's transition over to a bigger view. If you watch the box in the just where the time and date is on the CCTV, that's the camera, and you should see that rotate in a moment. Starting plan.
Start slew to NGC 604, right ascension 1 hours 35 minutes and 12 seconds.
There
Declination north 30 degrees 46 minutes and 30 seconds. Slew complete.
Okay, so we've rotated the camera 90 degrees, and the reason for doing that is to hope we pick up a better guide star, because the guider camera only has a tiny field of view, and part of the art of observing with this observatory is to actually get good guide stars, and I'm just kind of doing random things here, not really pre-planned. So I've just rotated the camera to see if we get better field of guide stars, and looking over on the observatory,
position synchronized to right ascension 1 hours 35 minutes and 8 seconds.
okay,
Declination north 30 degrees 47 minutes and 1 seconds.
that was a pointing update which succeeded. And it's changing to the red filter, and it's taken a guide star image, and there is a bright star on it, so we might be in luck here, although it's quite near the edge of the field of view. So we will see, won't we? Okay, so now it's gone down to a 2-second exposure from a 7.5-second exposure. The signal to noise ratio is, quote, very high. That's always a good sign. And the X and Y here, this is the position of the guide star on the guide sensor. And it is, 2 seconds final exposure. And it is now, we're on. There's the guide star. Nice and bright. Even looks remotely in focus. And okay, so we are doing a 300-second exposure through the red filter, bin 2x2. We wait now 5 minutes. I may go on mute because I've got a snack here and a cup of tea, and I don't want to make chomping sounds into the microphone. I'll be back when this first image is done. Okay, I'm back. The suspense is mounting. Almost finished our red image, our red plane. So what will happen is we'll take the red, green and blue planes and then I'll combine those into a colour image afterwards. So whether that will come out any good or not, I don't know, but we will see. And I will post that on the Beacon group in a comment where I posted the live stream link. Just saw the dome move a bit. It does track the telescope, so occasionally it just nudged to keep up. Okay, the exposure is done. We are... That should go to downloading. Sometimes it bypasses that. There is a moon out tonight. Oh, there we go, Triangulum Galaxy. There is a moon out tonight, so this can sometimes cause funny colour gradients on colour images, so we'll see how that works out. Let's have a look at this a little bit bigger. It's plate solved, I think. Solved, yes. 118 stars matched. Okay. That's got quite some good detail in it, hasn't it? So normally it would take maybe a dozen, maybe more images of the same thing, and then combine them all, and there's a whole bunch of reduction frames, dark frames, bias frames and flat fields that go into processing a final image, but I won't be doing any of that for these images. This is just a quick and dirty sort of shooting from the hip image. So yeah, I'm pretty pleased with that. It's black and white at the moment, as you can see, although this was taken through a red filter, so this represents red data, and the subsequent ones will be green and blue. So even though they look black and white, they're taken at different wavelengths of light. So when we combine them, we can assign a colour at that time, or we can assign false colour if we want to. Because colour is, you very rarely see any colour through a telescope. Sometimes you do. Like on something like the Orion Nebula, you can see colour. If you look at the planet Neptune, you can definitely see that being a blue colour. Mars is definitely red. The occasional star, like Betelgeuse, would be reddish in colour. Rigel would be blue, but it's quite subtle. And in most of these deep space objects, you can't really see any colour with the naked eye. And the camera, therefore, is a monochrome camera. It's purely measures intensity levels and not colour. So in order to get colour, we have to put colour filters in front of the camera. So this was using the red filter, so this is only red light hitting the detector. So this is confusingly a black and white image of the red light, a monochrome image of the red light. And as you can see, the green image is in progress, and you can see the guiding performance here is pretty awful, actually. What was that? That's 3 pixels. That's not too bad, but this suggests that the polar alignment is off for the telescope, because it's drifting and then correcting and drifting and then correcting. So it needs some work. I'm not going to be able to do it for a few weeks because I'm recovering from surgery and I can't really heft things around at the moment. So and I might be changing some of the equipment soon if a certain person comes through for me. There's been an offer of some new equipment, so that will be one to watch. If anybody would like a go at this sometime, that can be arranged. In order to access the observatory, you need to be on a VPN. It's all very secure because the university is very hot on network security. So there would be a few hoops to jump through to get you access to it. But if anyone does want to have a go, it can certainly be made available to you. You can contact me on the Beacon Astronomy group if you're interested in that. On Facebook. Okay, we've got our green image. It should appear in the thumbnail area soon. Sometimes it's hard to tell the difference. Sometimes it looks remarkably different. That didn't look too different, which is what you'd expect, because galaxies are primarily, well, usually quite a lot of white. And so a lot of the same light gets through the red, green and blue filters. So let's see if we can click that and have a close up. There she is. Triangulum Galaxy in green. So one more 5-minute image for the blue. And that's already underway. Filter blue. The camera, you can see here it's cooled to minus 35 degrees C. And the cooler is currently running at 46% power to keep it that cold. It can cool to up to 60 degrees below ambient, and ambient would be about 12 degrees at the moment. Alexa, what's the temperature?
At the moment, it's 11 degrees Celsius.
Okay, it's 11.
Tonight, you can expect a low of 8 degrees.
Okay. So it's not having to work very hard, and the reason this is cooled is because the CCD chips generate thermal noise, and the cooler you make it, the less thermal noise it generates, so you get cleaner images. And it's remarkably effective. The amount of noise something like halves with every degree you cool it, so you can imagine that cooling it minus 35 degrees, it really cuts down the noise to almost nothing. It's still there, but it can be removed by techniques, but it's under control, shall we say. Now I'm not liking the look of this smearing in the guider graph here. That you would hope to see that as a, ideally in perfect conditions it would be just a dot. So this suggests we've had some guiding errors. So that might manifest as stars that are not very round. They'll be oval in shape, or in some cases you might get a double star image, which is the... Let's have a closer look at this and see. There don't seem to be any doubles here, but there does seem to be smearing in more or less that direction. So the guiding's not perfect, and that will mean that the colour planes don't line up perfectly, so there'll be fringes in the final image. So yeah, guiding has never worked very well with the equipment I've got at the moment, so that is one of my bugbears. Proceeding normally. We can see down here, whilst that's going on, pictorial camera field. So this will show us what the telescope's pointing at according to some... No, that doesn't seem to be working. That's a shame. Oh, there we go. Okay, so that's the... I think it uses the Sloan Digital Sky Survey or something like that to basically, here's one we prepared earlier, and so this is the thing we're taking an image of, and this is what my final image would hope to look like. And it won't be anything like that good, I don't think. And then we can see the weather that's... Oh, the weather's disconnected at the moment. I disconnected the weather station because it was reporting 50% cloud cover, I think incorrectly. We can get a report on dawn and dusk, sunrise and sunset times. So tomorrow morning, dawn is at 7:09 and 23 seconds. And we can look at the weather station and see what the current weather is. Okay, so it's 9.1 degrees outside, 56% humidity. Interesting, that's a lot lower than is currently being shown elsewhere. No wind.
Tracking off.
Barometers falling by the looks of it. And you can see the temperature's dropped off from 16.
Start slew to NGC 960. Right ascension 2 hours 29 minutes and 57 seconds.
All
Declination
right,
south 8 degrees 42 minutes and 11 seconds.
Okay, the imaging run has finished and the observatory is now shutting down. So we will transition over to the video link to watch that happen, and the shutter's closing now.
Slew complete. You
can see signs of cloud or fog up here.
Parking.
Through the shutter. The telescope's parking itself. And
park complete.
There she is, all tucked up for bed, nice and safe. And the one thing that hasn't happened there is the front cover hasn't closed, so we need to just manually do that. I'm going to try and send a manual command to do that. Send. There it goes. That's the cover closing. Good, good. And shutter. Okay. Observatory offline, telescope offline. The imager hasn't gone offline, interestingly. Oh, the cooler's warming up. Okay, there we go. It's only at minus 19 now. It was at minus 35 earlier. So it looks like it's trying to warm that up slowly. There's no need. S-big cameras don't need to be warmed up slowly. Okay. So I guess that's shut down. So let's see if I can find the image. What we would do now is we go over to screen capture and transition to that, and then I can close this down, and the CCTV and sky charts, and we can get the observatory desktop up. So there was the last image that came in, and if we zoom in on that, we can see it's quite fuzzy, really, quite fuzzy. So now, can I find those images again? Who knows? Let me just check that this is coming out correctly on YouTube. Yeah, looks good. Okay, so we will look for TAO ACP ACP. No, I don't. Where will they be? Scheduler or interactive? They're not there, are they? Date modified. Oh, that looks like it. 2022 11/13. Here we go. M33. Red, green and blue. Okay, so we'll open those. So we now have all three of them open. So what we can do is we can... I might calibrate those, or I might not. Let's just not for the moment, and then so we can process them by stacking them. There we go, and we can add images Add all. OK. And then we can go with align, mode astrometric. Where's astrometric? There we go. And we can compute all. And those images are now aligned with each other, because you can't assume just because you pointed the telescope in the same place that they're all aligned. So just step through those quickly. And yeah, that's not looking too bad. So the reds and the greens here represent image misalignment and noise, so that's not too bad. And then we're going to colour combine colour. Why are we not group 1 no object? Okay, it was M33. Why is it not? Oh, we didn't classify by filter, that's why. And extract the object. Okay, filter. That's good, that's good. I think we might need to remove this group and start again. So remove item. Okay, add images, add all. Okay. Alright, that's better. Now we've got red, green and blue filters. So now we should get a better... Yeah, now the colour box has come alive, so red, green and blue. Why is this conversion colour space? We're not converting, so we will combine. There's no we'll just sum them because there's only one of each, so there's nothing to sum. And we will combine to new image. Go. Okay, so there is our combined image, and it's not awesome by any means, but it is a colour image of M33. There's work that you could do on that, adjusting the colour weights and so on. There's a very red orangey cast to that, which isn't probably correct. I'm just running it through a filter to improve the oh, that's a bit washed out now, isn't it? That's weird. Okay, background, that's background is there. Yeah, okay. That's kind of no, don't do that. Okay. So you can play around with this for a long time and not get good results. So I'm just going to set everything to auto. And that's our final image. You can see we've got these red areas here. There's probably hydrogen rich areas. Let's get the crosshairs off. And then I can let's reprocess that. I'm not really happy with that. Process, filter, digital development. I don't know if I just don't prefer it unprocessed actually. Alright, let's save as. We'll just save this on the desktop here. M33 RGB.fits, and then we will try to save as a ping file that I can upload to Facebook. Ping 16-bit manual stretch max pixel. Here we go. Yeah, that looks good. That's not working too well, is it? Okay. And save. And where are we? Did I save that on the desktop? I thought I had. Oh yeah, yeah. Oh, there it is. Okay. It is probably not interesting anymore. Oh, the cloud cover's reduced as well, interestingly, to 40%. Come on, but a 12-year-old computer, what can I say? I've right-clicked on this image and it's just like, oh, maybe I'll do something. Maybe I won't. Oh, goodness me. Alright, so you probably don't want to stay and watch this. It's about as much fun as pulling teeth. I'll post this image on the Facebook page just under where I link to the live stream in the Beacon Astronomy group, and that will be on there shortly. So with that, I'm going to sign out of the stream. And thank you for watching. If you're still here, especially, thank you for watching. And maybe if you want to go on the observatory, let me know, and we'll make it happen. And or until next time, thanks again. I've been Tim from Timtek Systems. Thanks for watching, and